Alright, students, hello and welcome to this lesson on finding the missing angle of a right triangle. Today we're just doing the examples that go with the actual notes that went for this lesson. So these are just the examples. If you haven't taken the notes yet, go ahead and do that now. Alright, so we're going to start on example 3. Now we know that we use inverse trigonometric functions to find a missing angle, right? Because that's what we learned. We wanted to find a missing angle in our notes, right? So we had to come up with these new functions, these inverse functions, to be able to find a missing angle as my output. So we identify that we are trying to find an angle, right? And it's helpful because we've got this handy little symbol here that means that x is some angle that we're looking for. So I know that I'm looking for an angle. Now, I want to identify which of my three inverse trig functions I want to use to be able to find that angle. So, I want to identify the side lengths which I'm using to help me choose which of my three functions I'm going to use. So, I know that the 4 is going to be the opposite side because it doesn't touch the angle at all, and it looks like the 5 is the longest side, or the hypotenuse. So I have O and I have H. So if I look at SOHCAHTOA, then I see that O and H are going to be sine, right? So in this case, I'm going to use the inverse sine function as my function. And I know that I want my final output to be this x, so I want my final output to actually be this value here. So at the end of the day, I want to have some degree, which will be output. We know that our inverse sine function is going to need an input, which is a ratio, and it's a ratio of O over H. So I say 4 over 5, and then this is something that I can directly plug into my calculator. So I plug this in, and I see that x is approximately 53 degrees. So I know that x is going to be 53 degrees. Alright, great. Let's move on to our next example. So we're looking at our next example, and again, we know that we're looking for some angle here, right? So I want to now identify which of my three inverse trigonometric functions I want to use to find that angle. So 13 is the opposite side, 21 is the adjacent side, so what I can write is I have opposite and adjacent. Well, that looks like I'm going to end up using the tangent here because I have the opposite and adjacent side. So I say inverse tan, or tan minus 1, of something is equal to my x naught. And I know that tangent uses the ratio O over A. So I've got my opposite side, which I identified as 13, over my adjacent side, which is 21. Alright, and again, let's just plug this into our calculator. And I'll see that x is approximately equal to 32 degrees. More accurately, this is going to be x is approximately, I could call this 31.76 degrees. But the thing is that this is so hard to actually measure, right? Degrees isn't made for this level of accuracy. So you don't typically report a degree of that accuracy. You're going to report a degree of 32 because that's how precise a degree actually is. All right. Let's move on to our next example. Alright, so now I'm going to be making this a little bit more complex. So I'm going to find x, and now I'm also going to find a length, which will be called y. So in that problem, and in this problem, we're also going to find the length y. Alright, so for example 5, we're starting out, we know that we're trying to find some angle, right? So we're going to first identify the sides that we have. The 7 is going to be our adjacent side. The 9 is going to be my hypotenuse. So I have adjacent, I have hypotenuse. That tells me I'm going to use the inverse cosine. So inverse cosine of my ratio here is going to be A over H. So my input is the ratio of 7 over 9, and that's going to give me my output, which will be some degree. So I take 7 over 9, and then I'm going to take the inverse cosine of it, and what I find is that x is approximately 39 degrees. Okay, great. So I found that x is approximately equal to 39 degrees. So now here's where we get interesting, right? So I want to find y now. Well, I know that x is 39 degrees. So what I can do is I can actually say, okay, well, I'm looking for y. Y is going to be my opposite side. And here I've got some choices, right? So looking at SOHCAHTOA, I only ever need 2 pieces to be able to make this work. So I have my choice. In this case, because I want to make it easy, right, I want to do this in the easiest way possible, I'm going to choose to use O and H. So I'm going to use my sine function. So I'm going to say sine of, now I have my angle that I can actually work with. So I'm going to say sine of 39 is equal to my ratio, which will be y over 9. And so to find y, I just multiply both sides by 9, and I'm going to get that 9 times the sine of 39 is equal to the value of y. And so if I put this in my calculator, I find that y is approximately equal to 5.66. And I want to estimate this, right? I want this to be a little bit tighter of an estimation because this is a more accurate type of measurement, right? Degrees actually has some limitation to it as far as a measurement system goes. When I'm just talking about a length, it's a lot easier to measure length precisely than it is to measure degrees precisely. Alright, so let's work on our final problem. It looks like x is right there, and so I'm going to identify my sides. I have an opposite side here, and I have a hypotenuse side here. So, opposite, hypotenuse, that tells me I'm going to use my inverse sine function here. So I'm going to use my inverse sine. My ratio that my input is going to be opposite over hypotenuse. So that's going to be 104 over 185. And so then that's going to give me my output as x. And so I plug that into my calculator. And what I'm going to get that this is approximately, x is approximately 35 degrees. Okay, and now we just have to find y one more time. So, again, I'm going to use the thing that will be the easiest, right? And in this case, I'm going to look at how this is now my adjacent side. So I have my adjacent side. So now I'm going to say, well, I want to use my adjacent side. Might as well choose cosine, right? It's not a huge deal which one you choose to use here, but in this case, I'm just going to make the executive decision, and I'm going to use cosine. So I can say that the cosine, and now that I know my degree, right, I know that it's cosine of 35 degrees is equal to, now I'm going to use my ratio, right, and I have my adjacent side, which is my missing side, over my hypotenuse, which is 185. So again, we have 185, and we multiply both sides by 185. And what we'll see is 185 times the cosine of 35 is equal to y. So let's go ahead and plug that into our calculator. So we've got 35, the cosine of 35, multiplied by 185, and that's going to give me approximately 151.54. So y is approximately 151.54. Alright, now that you guys have done your examples, make sure that you start working on your maze and then also on your angles of elevation and depression, solving for the angles. Both of these assignments are going to be due on Thursday. Have a wonderful day, and let me know if you have any questions. Goodbye.